This is a video recording on how to repair a ultrasonic humidifier, specifically a Humidifirst Ultrasonic humidifier. My name is John Ostert. I'm with Computer Room Industries, and I maintain these types of humidifiers for a client of mine. And what I'm going to do is show you the techniques that I use to repair this type of humidifier. Now, this video training session is relatively long. It's a good 45 minutes long. So because of its length, I put a menu system in it, and you can get to that menu system down in the lower right-hand corner. Now, if you don't see the menu system, that means the player that you're playing it back with does not support it, or you may be watching it on YouTube. So if you're having that problem, you can go to this website address below and look at it. You'll be able to look at the menu system, or you can look at this menu system I'm just about to display on the screen and get an idea what's in this video. If you can see the menu system in the lower right hand corner, that gives you the ability to click on the links and it'll go to that particular area, and you can start watching the movie there. If you don't have that ability, you can't do that. You've got to scrub to the area that it is designated with the text on the screen. This happens to be, like I said earlier, a Humidifirst DT80. It's actually sitting on its end right now, leaning up against a wall, and it doesn't have its bottom plate on it, and the water goes inside this dish bowl here. But this happens to be a video I made of repairing this humidifier. I was actually wearing a headset with a camera on it, a GoPro Hero 3 Plus video camera, when I recorded this session. So I'm going to start here to play this video back and describe to you what I do to repair this humidifier. So here we go. So I'm going to begin to pick up this humidifier and put it on a stand that I made that I use to examine and repair these humidifiers. You can see that the stand is made out of PVC and it supports it on the four corners. And we'll stop the video here. It'll go a little further. You get an idea what this stand looks like. It's like 1.25 or 1.5 PVC, and it's just, puts it up in the air about 4 feet, 4.5 feet, so you can look underneath it and do the repairs. So we'll continue on here. So one of the first things I do is I've got this drain pipe that I put on the drain, and all that drain pipe does is to actually empty the water back into that bucket. You can see it's got a valve on it that I'm going to turn there, and then I'm going to pick up the bucket and fill the pan with water. Now this happens to be Humidifirst's largest humidifier, DT80, and 80 meaning 80 pounds per hour. Now you can see that there's these little circles in here, and they're the actual, we'll call them transducers. They're actually technically called nebulizers that actually produce the mist, and you'll see how they work here in a little bit. But with this 80 pound per hour humidifier, there are actually 62 of them. So there's 3 rows here. There's a row down here that's got 21. There's a row here that's got 20, and then there's a row here on the back side that's got another 21. So you add that up, that's 62 transducers or nebulizers that create mist. So we're going to start the recording here again. And what we're going to do now is to hook up a power supply, and it happens to be this right here. And this is a variac that puts out a variable voltage, and we're going to take that and hook it up to the terminal strip of the unit to put power and start running the transducers. So here we go with the cord that I've got to start hooking it up. then here's a better picture of these transducers here. A little clearer picture of the nebulizers. So start this again. And so I am, screwing down this power supply to it. And since there's 3 rows, there's 3 different sets of power. So right here are 2 terminal strips. There are 2 terminal points that some power goes to. Here's 2 more, and here's 2 more. So 1 through 6 is some power. The rest of these are control circuit terminals for controls. So I'll continue on here. So the voltage that goes to these transducers is 48 volts AC. But that variac that you saw has the ability to regulate that voltage, and so what I end up doing is I regulate that voltage down to around 30 volts, and then the transducers don't fire very hard. They don't run very hard, so they don't splash water all over, because that's what would happen if you turned it up to 48 volts. So, and the idea behind this is that I can determine which of these transducers are not working. So I come over here and I turn on the switch and I cause all these transducers to turn on. And here we go. Now I've got to plug it in first. Okay, so there they're running. Now, like I said, I've only got 30 volts to this. If 48 volts to this was going, these little spouts that you see here would be quite large, and you'd have mist coming out of them, and that's how the humidifier works. In fact, you will see that towards the end of the video. I'll turn up the power supply a bit to show that the mist comes out pretty good. But what I do right now is I document which one of these are out. And you really can't see it very well, but actually it's this 5th one here. I think it's the 5th one that's out. And then a few more. There's actually, within this module, I'm going to count 11 transducers that are out. So we'll continue on here. So you can see that they're putting out just a little mist, and there I pointed to one. There's another one. And so I'm pointing which ones are out. I'm going around the other side to point to these, but that actually wasn't a very good idea because the lighting is not very good. But you still get the idea. So now what I do next is I actually document this, which ones are out. So I've got my iPhone in my hand, and I get out the text editor, and I write down in a number formula which ones are out. 1, 2, 3, 4, 5. So I write 5 down, put that into the text editor, and then I go through and I document every one of them. So what I'm going to do here is I'm going to scoot forward a little bit and get to the point where I'm just about done counting. I'm going to, we'll call it row number 3. And in a moment here, I think you'll see my little list of the units that, or the transducers that I have out. You'll see it a little later, but now what I'm going to do, since I know which ones are bad, I'm going to go over here and drain the water out of the pan. But I did make one little quick mistake here, is that I started the water flow and I hadn't shut off the transducers yet, so I had to shut it off. And actually, I realized I kind of made another slight little mistake, and that is I actually did not have to take off these wires off again. There was no reason for me to take them off. I think I was so busy, so concerned about the video that I was taking that I took them off, and I really didn't have to do that. I could have repaired those transducers, which you'll see here shortly, with all those wires on. So I've drained the water out of the pan, but yet there's still a bit of water kind of laying in the bottom here. And so what I do is I kind of lift the pan up a bit from the opposite end, and then let the water drain down to this corner down here, and then go into the bucket down there. And that's just to get more water out of it, so it doesn't splash a bit when I start taking these transducers out of their holder, onto their where they're held in. So that's what happens next here. So I'm kind of lifting the pan up, and I just lift it up about 3 or 4 inches, you can see, and you saw here's the bucket down there, and then the water is draining additionally. And actually I take the pan and I turn it, I tip it about 15 degrees to the right to get it to go out the drain hole. So now most of the water is out of it. I get another 6-8 ounces out of it. And now I'm going to look at that text editor. It's actually a notepad, and you can see that here's the numbering system I use to count which ones are out. So if that first row has 21 transducers in it, first row had number 5, 13, 17, and 19 were out. The second row has 20 transducers in it. Number 27 and 41 were out. 41 happens to be the last one in that row. And then in the third row, it starts at 42, 46, 48, all the way up to 58. So those are the numbering systems I use, 1 through 62, and I just count each row, and I do a carriage return and show which ones are on each row there. So that's how I start my repairs. All right, so you can see that I picked up a drill there. Set my phone down. I'm going to grab my chair and I'm going to go over to the other side and start at number 5 and take the actual transducer and what's called the print plate out of there. So I'll stop it right here, and you can see that I counted the transducers modules 1, 2, 3, 4, 5, and I got my finger on number 5. And then each one of those transducers, actually a nebulizer, are driven by one of these printed circuit boards here. And you'll get a better look at it here. Let's take a look over here. So here's a heat sink area, and then here's a board in here. It's got 4 wires on it. 2 of the wires go to the actual transducer itself, and 2 of the wires are from the 48 volts power supply, or that terminal strip that I put the power on. And so here's the 2 power supply wires. And again, I was testing it at 30 volts, but that's the first one I take out. So I counted that one. I actually grab the wires from it, and then I pull the wires off that printed circuit board. So I pulled the 4 wires off, and I went in there, and there's 2 actual bolts, that nuts that come off to take it out of there. You can see I just pulled it out of there and put it on the floor. And now I'm going to take the transducer out of there. Again, there's two screws that, or two nuts that hold that into place. It's interesting. I have a little trouble getting this one out, and generally that's not the case. Generally they just fall right out, but the threaded rods, that's a pretty good picture there. Well, it's actually the studs that are welded into the stainless steel frame here, the stainless steel tub that holds the water right here. And these are spot welded on, and they're a stainless steel stud that's about 3/4 of an inch to an inch long that a nut goes on, and that nut happens to be a 4mm nut with a star washer built right into the nut, so you don't have to actually use a washer. It's a swivel star washer that's built right into the nut. But again, I was having a little trouble getting that one out, and they usually fall right out. So I'll start the video here again. Come on, you. Come out of there. There we go. So I put those over the side. I'll show you what it's like here, what another shot what those transducers are like. But there's a couple of bolts I'm putting to the side, trying to keep track of them. So now I go to basically all those transducers that were out, and take out the print plate and take out the printed circuit board and replace them. I'm going back at it here. So probably what I'm going to do now is to scrub forward the video and get to the point where I'm starting to replace them. But as you can see here, I'm coming over to the opposite side now, and oh, here's an interesting point. I'm going to stop the video here. Okay, I scrubbed back a little bit, but I'm holding up my drill driver. This is a small Bosch battery-powered drill driver pack. As you can see, it's got a DeWalt bit on it. I forget the size of this. It's like 5/32 here. But I'm pointing to number 1, and actually number 1 is used to tighten down the transducers themselves, the nebulizers to the bottom, and we'll go over this again. But then number 3 is used to tighten down the actual bolts on the printed circuit board itself. Printed circuit board goes on there, and it's actually the heat sink that is pressed up against the stainless steel metal. But you can't tighten these transducers very much. They don't need to be tightened very much when you because it's just in a open bath of water. And you will see I'll show you here in a little while, the O-ring and actual rubber gasket that's used to seal this transducer nebulizer to the bottom of the plate. But this Bosch is very light on its number 1 setting. It hardly, it does not get very tight, and actually it's ideal for lightly setting these transducers, the nuts back onto the transducers, and not really pulling it down real tight, because it doesn't have to be pulled down. It's not supposed to be pulled down very tight. And this Bosch is very light. I have worked with other drills, and they are too strong, basically. They'll pull it down too tight. Not that it's going to hurt it at all, but it just doesn't have to be pulled down that tight. So the Bosch was a very good unit to do this job, because it barely has any torque at the number 1 setting, and it's just what I want. Now, when I'm taking everything off, I generally have it at number 3 or even number 4 to take everything off. But I got to make sure that I go back to number 1 for the transducers, and number 3 for the putting the printed circuit boards back on to the side of the, the bowl here. I can't find the right word for it, but you know what I mean. So we're going to start the video again here. And now you see me turn it up to 3 or 4. And now I'm going to go about my business of removing them. So I'm counting up again. I think 46 was the first one. And take off the wires. And these are better pictures of the transducers because the lighting is better on this side. So I'm going to pause the video here. Oh, I'm pointing something out here. This is a good place to stop. You ask yourself, why do these boards fail? And I haven't really pinpointed exactly why they fail yet. In fact, they don't seem to have any real pattern, I'd say, to why they fail. But there is one thing that does cause some of them to fail, and it seems like it's about 30 to 40% of the units have this. There's a very small little resistor in here that actually blows up, and you can see that right in there. It's actually burnt. It should look like this one right below it, but it's actually burnt. So it's had too much power going through it, and it's actually caused it to burn up, short out, or open up, but it's caused the board to fail. But again, not all the units, all the boards have that happen. Sometimes it's the board that fails, sometimes it's the actual nebulizer transducer that fails. But when you do repair on them, it is wise to just replace them both. And not that it's really wise, it's just too much time consuming to troubleshoot and determine whether it's the board, whether it's the transducer, or whether it's both. So if you just get a whole new set, you put them in, you know it's going to work, and you know you got fresh components in that particular spot. And you can hear, I've heard these things pop before when I've had it on this test stand, and maybe I had the voltage turned up a little higher, but all of a sudden you'll hear this little pop. It's more like a snap that you'll hear it, and you'll smell a little bit of electronic smoke, and smell a little bit of electronics, and you might even catch a little bit of smoke coming off it when it actually snapped and popped. So, but other than that, I really haven't been able to pinpoint why these things fail. They do have a life expectancy, and typically it's they say between 10 and 15,000 hours. Well, that sounds like a long time, but that's really only about 2.5 to 3 years worth of operation of this unit. And you'd like to see them last longer, and typically they do last longer. This particular job that I'm working at has deionized water, has very clean water, so those pans never get dirty at all. So it's not a case of the water getting dirty. It's just life expectancy. Some of them fail before 10 to 15,000 hours. Some of them have lasted 30, 40,000 hours and are still running. These systems have been in here since 2008, and probably 50% of the transducers in this whole site, which there's a lot of them, are still running after 7 or 8 years, which is exceeding life expectancy. So, and then, to replace these is pretty expensive. These things are basically about $50 a piece, the board and the transducer himself. So you have 50 times 62. That's a pretty spendy repair. Parts alone is $3,000-4,000. $3,500 plus labor, and to replace all these, if you were to replace them all, it's a good 4 or 5 hour job. You got hundreds and hundreds of screws to do it. So just a little insight there. So again, you'll see these little pop transducers, and that's actually when I take it apart and I start when I count them and I start looking at them, and when I replace them, that's the first thing I look for to see if whether that little resistor is popped or not. So let's move forward now. So I tried to do a little bit of close-up, but actually the camera in my head didn't quite do it right. Didn't quite know where it's going. So again, you can see that there's, this is a better shot on this side, that there's two nuts. And then these boards are a little bit stuck onto the side of the tank that holds the water. And you'll see that this transducer, when I took it out, just falls right out. Boom. So I don't know why that other one was so hard. The actual pins were bent, I would imagine. So yeah, I'm showing you it again, where that resistor is. And this gives you a little better, I missed it, a little better shot at those, the studs that are welded into the side of the casing itself. So I'm going to count again, and this row had 5 of them out, but so I'm going to scrub forward here on the video and get to the point where I start putting them in. So pause the video here for a second. Here's a better shot of the resistor that's burnt. You can see it pretty clearly here that it's kind of brown. Black, basically. So just thought I'd point that out. Now here's a picture of the underside of the unit, and this was hard to video, so I'm just going to really show the picture here a little bit. But you can see here's the ones that I took out on row number 3, and look what the underside, and then here's the middle row that I'm going to take actually 2 out. So a lot of wires under here, and it looks like it's kind of a mess, but once you narrow it down to one particular one that you're after, it's not that hard to work on. But I just thought I'd show the underside here. So here's another picture of the underside. This happens to be we'll call the front end of it, where the terminal strip is. The terminal strip is actually up under this box here, but the configuration of the printed circuit boards that are down here gets a little interesting. And what I mean by that is this particular transducer right here that's in row number 1, its wires actually go to this printed circuit board over here, which is basically lined up with the middle row. And then the last printed transducer nebulizer in the middle row, which is right here, is actually fed by a printed circuit board that's kind of out of its place a little bit in between row 2 and row 3. So just to point out that at the end here, the printed circuit boards get a little bit out of line from where the transducers are. But again, you look at it for a little while and it's not hard to figure out. I'm going to show a little video of me working in that area just to show you what it's like. Here I'm drilling actually that last board that's kind of in between the 2 rows, because that one was actually bad. But it's a little bit of a confusing area, but again, it's not that bad. Now I'm going to go up and take out the transducer for that one. It comes right out. that's enough of that. Now I'm getting ready to start putting some new ones back in. And this is underneath the table, my little workbench. And this is kind of a box that the actual printed circuit boards come in. So you can see that there's a foam side in each. There's 10 printed circuit boards in each one of these slots, so the whole box itself holds 80 printed circuit boards. I'll start the video here. Now, each one of them is wrapped in its own little padded plastic envelope. So since I have to replace 11, I'm going to get 10 out of here at first and basically get them out of their bag. And then I do the same thing for the nebulizers, the transducers themselves. So you can see that each one's in a little bag, and what you have to be careful with is to get these bags, at this particular job, get those bags down in there, because there is a lot of turbulent air blowing in here, because this is I'm inside an air handler, and so there's a lot of air movement, and I don't want those bags to get sucked up into the air handler. But so I'm gonna, and really what I'm doing is I'm just kind of lining enough up for a series of repairs. And I'm going to scrub the video forward here a little bit. Here I've got almost all 10 of them. In fact, I grabbed the 11th one there to get out of its package. All right, now I'm going to move over to the stockpile. That's all old junk stuff that's in there. I'm going to move to my stockpile of transducers. Now they happen to come in little plastic bags, and there's 2 to the bag. So I'll get another 10 of those out. But this is another interesting point that I'm going to point out here, is that some of the leads are long and some of the leads are short. What I'm taking out of the bag there are 5-inch leads. Now what I'm taking out of this bag are 9-inch leads. And there's particular places where we use the 5 and we use the 9-inch leads. So I'll show here that they're wrapped, coiled around, and they're longer. And there is a reason for that. So I'm going to get 4 of those 9-inch leads out, because you don't use as many, and I'm going to get 7 or so of the 5-inch leads out. Again, put those bags in there so they don't fly around. And I'm showing the 5-inch leads. Now I'm going to just grab a few of them in my hand and grab my drill and start putting them in. Typically I'll work again out a row at a time, and I'll just set them in there at first, because these aren't going to fall out. When you're working on the middle row, it's a little bit more difficult, because they'll just want to fall back to the floor again. So So that's pretty straightforward. You put them in there, you screw them in. And again, this is where I use, stop the video here. When I put the nuts back on these and I tighten them down, I use a little bit tighter torque setting. Again, I've got my Bosch set at number 3, and when I put them in, when I put the transducers back on, I have the Bosch set at number 1. One important point about that is that these are welded on. If you do go a lot stronger, you'll break these pins off, and so then you're kind of SOL for maybe putting it back together if you were to break both the pins off. Now, it's quite rare that you break a pin off, but I have done it before. But that's why you want to keep the torque settings somewhat like, so you don't pull those pins right out of their spot weld socket. I'll put a couple more in here and then we'll move on. So you're beginning to get the idea and what's, I'm sure you're getting the idea of how to repair these things, but it's not too difficult. But there's a few key things that you have to do and have to know about to do it right. And I've covered a lot of them so far, and we'll go through the rest of the video here to a degree, see if I can determine a few more. But now here's where I'm making sure that I'm setting up the drill to number 3 there. I'm setting it right now. You can't quite see it, but that's because I can't quite. Oh, here's another thing that stop the video here in a second. There's a lot of slop within this hole. This hole within the heat sink. This is actually the silver part is a heat sink. It's quite a bit bigger than the actual bolt itself, so that when the plate goes in there, there's a little bit of slop. In fact, you can see it over here with one I set in there. So you want to kind of try to line them up with the ones that are in there, because they will touch each other, and it probably wouldn't hurt each other if they touched over here. But so I grab the actual plate and I kind of line it up with the other ones, and then I tighten down one bolt, and then I put the other ones on. So we'll take a look at that again. And I do put the bolt right onto the nut, and here I'll put another nut into the socket, and I'll grab that plate and I'll adjust it somewhat straight with the other ones and put it back together. So it's an understandable tip. That's kind of nice. Now this part of the video is kind of interesting, and this is where I have to put the transducers in the middle row. No, actually I'm not putting them in the middle row. I'm putting them in the first row. But anytime you put the transducers in, it gets a little difficult to lift it up there and then put the screw in. So you really have to put it up in there, and you actually have to put one screw in by hand to make sure it doesn't fall out. You're not seeing it here, but yeah, you got to put one in by hand, and really it's the only way you can do it. It's hard to do it and hold the drill at the same time and then drill it tight. Maybe this will be a better shot. Yeah. So you got to get it up in there, and now I grab a nut, and then I got to screw that nut on there to hold it in there halfway, and then you can use the drill, the Bosch drill after that, to put the rest of the nuts on and torque them on with number 1 setting. Now the next thing I'm going to show you it has to do with the lead lengths. You saw that there are 2 different sizes of lead lengths, and where you use the longer ones is towards the front of the unit. And I'm finishing tighten that one. Now I'm going to grab a longer lead length. There we go. And you can see that I'm showing it to you right there. So what happens as you get towards the front of the unit, the distance between the boards and the distance between the transducers starts to get different. And what I mean is the boards become longer, and they become further down the length of the humidifier. So you actually need longer lead lengths in order to go from where the hole of the transducer is to the actual board. I'm going to back up here just a bit. Let's see if I can do this. There, watch this. Right there. So you can see that transducer goes in right there. but then the actual leads go to this guy over here, or maybe even this guy over here, and you couldn't do it with the shorter ones. So 2/3 of the unit use short leads. The last third towards the front where the power strip is uses longer leads. Now there's a couple of exceptions in there that you'll see, but that's generally the idea. Boards start to get further down the unit than the transducers, and you've got to use longer leads. We'll see what happens here. Oh, this could be an interesting part. I dropped the ceramic, we'll call it the washer that goes on the bottom. So here I'm going to show this to you. This is an important part. You've got a transducer that has a little rubber disc to it where the transducer is itself, and then on the bottom of the humidifier itself, this ceramic washer assembly goes up against the pan. And I'm showing you the ceramic washer, and now I'm going to show you the actual rubber O-ring that goes with the ceramic washer. So you've got that goes up there, and then here's the rubber O-ring. So that's the thing, the O-ring that actually touches the bottom of the plate, of the pan. And then the actual transducer itself goes into the bottom of that ceramic holder of the O-ring, and then it goes into the unit. So very important part there that probably should have talked about earlier, sooner, but I'm glad we got it covered. Now we're going to talk about wiring it back up, because there is a particular pattern to the wiring. And you can see here, we'll take this middle one here, that you've got a blue wire here and a yellow wire here, and this blue and this yellow wire are connected to the transducer nebulizer itself. So, and as you probably saw that earlier, that each one of the transducers has a blue and a yellow wire on it. Now, they always go in this particular order. Let's say that the yellow one is always the closest to the edge, and the blue one is always in the middle and closest to this I forget the name of it, but this is a driver. This is a driver chip here. So the blue one's always in the middle, and the yellow one's towards the edge. And that is the transducer. Now over here we've got a white and a black. So this is the power coming in. This is the 48 volts AC that comes into the board. And here you can see it's a black and a white. And they have to stay in that order. The black is towards the middle and the white is at the edge. And you get the feeling of that quite a bit. I mean, you'll pick up on this because they're all the same. If you question what you're doing, you look at the one that's already in there and you know how to put it together. So here's the board I replaced over here, and you can see that this doesn't have wires on it here and here. So we're putting the wires back on that. I'll start the video. And there's the new transducer that we put in there. And I'm going to basically take the blue wire, I think, first and put it up there. Oh, I'll put the yellow one in first. They do have a little plastic coverings over each one of the wires. They're, a electrical cover for the spade itself. Yeah, my head is too high on this, so yeah, it looks like I'm putting the other ones on, but I'll pause the video here. Now, one thing to note here, as I put on the black and the white wire, that I talked about the transducers themselves having the blue and the yellow wire, and I talked about a black and white wire here for the power supplies. But the other rows have different color wires. They are not black and white. They are, I haven't got it memorized, but they're different colors. So black and white, this is row number 3, I call it. Row number 2 doesn't have black and white. It's a couple different colors. And row number 1 has got different color wires too. So maybe we'll see that again here, but just to point that out. So there's putting it on. We'll move on here from here. Stop the video. Now here I'm pointing it out. You know, black, white, blue, yellow. Black, white, blue, yellow. So now what we're going to do is to test it out. So this is the point. Let's just say that we've repaired all the transducers. Oh, and then here's the thing, something I forgot. I forgot to shut that valve. And I do that quite a bit because, as you can see right here, oh shoot, I gotta scrub that back. As you can see right here, I have spilled some water. And again, I do forget to close that valve off every once in a while. It makes me mad. Alright. Alright, so we'll fill it back up with water. Scrub forward here a little bit. We'll put the power back in, which again I didn't have to do. I could have left it on there just with it powered off. I'll scrub forward here a little bit more. Okay, here's something. So, well, and this is just the way I did it. You know, I got a black and a white and a red and a yellow and a green and whatever. But I got little pieces of tape around the positive side of the 48 volts and the negative side of the 48 volts just to show that that's how I kept track of them. Simple enough. Okay, we turn it on, and they all work. Walk around it, take a look at them. Give it my thumbs up. Make sure my thumb is in the video. So now here's one other thing that I'm going to do. I'm going to turn up the voltage on this variac a little bit to show you what it's like when the transducers start firing a little harder, and to show you why I do it at such a low level. You can see them other ones working in the background there. So here we go. And the reason I don't do this is because it starts to splash a lot and kind of creates a mess, and you don't want to get any water down where those transducers are. So and that was only going up to about 38 or 40 volts. So when you get up all the way to 40 volts, or 48 volts, you can't even see those transducers. That's the end of the video. Well, went to the beginning. So you can't even see those transducers. Those ones that were running in the background there, you lift up the cover and you can barely look in there because there's so much mist coming out of there, and it's hard to determine which one of these transducers is actually out. And that's another benefit of putting it on that stand to see, to see what's going on a little bit more clear, because when they're running full blast, there's so much fog in there you can't really tell which one's in or which one's running and which one's not, unless there's a lot of them that are out. So that's the end of this video. I know it's quite long. I apologize, but that's it. Thank you very much for watching, and stay tuned for more videos.